Okay, I'm going to try to be as clear as I can be on this. I know it's a little bit confusing, but I'm trying to figure out the optimum way with least amount of expense and the most efficient way of using what I have material-wise in the ways of wire and or possibly getting more materials from like local supplies, common type wiring, and using the least length of wire that I could possibly use between devices. So what I have here is a sketch of the way I propose to lay it out. Optimally, I want to have only 4 connections to the battery bank. So there's going to be the positive and negative to the charge controller and the positive and negative to the inverter. And those are the only connections I want to see off of my battery bank. The other thing that I need to do is add switches. Like I need to put the amp meter right between the battery bank and the charge controller. That way I can actually see the total amount of amperage that I'm gaining throughout the day, throughout the usage of the system. And the other thing I need to do is I need to put an on-off switch to the AC charger that I'm using in the wintertime. I'll have the batteries on float charge. And the only problem with this is it doesn't have an on-off switch, so you got to actually unplug it and plug it back in. It's kind of a hassle. So what I need to do is just have that, so if I want to turn it off like in the summertime where I'm getting lots of charge and it's not, depleting the batteries down so much, that I can just turn that off with a switch. The other thing that I'm really having a problem with is the inverter, because the inverter, when it's running, it's just using power, even if you're not running any appliances or anything off of it. So when you have it on all the time, it drains the batteries just having it on. I mean, even if it's just sitting there in standby mode. And the other problem is I want to mount it so that it's optimally the length from the wire, the length of the wire to the battery bank is neat, and then I have these SunForce panel kits that I had. The first ones that I have in the Harbor Freight one. What I need to do is combine all of the wires, plus, 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 minus, 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 and maybe get rid of the existing charge controllers, the 7 amp charge controllers that I'm using, and then combine those onto a bus plate. That bus plate being also combined with the Siemens and then the Kyocera's that I have proposed to have portable mounted on a ladder. And those I can just mount and then have them be able to move them on and off the roof when I want to. And then those other 2 Siemens, I'll piggyback those like I was saying before on this rack of the other ones that are there. The other thing that I've done is I went out and bought some copper plating, a 1/16 of an inch copper plating, and I need to cut it in half and use that as a combiner. So I'll combine all the plus, 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 all the minus, 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 minus onto each side of the plate, and then from that plate it'll go to the charge controller. So everything will be running through the Xantrix charge controller. Then once everything's combined going to the Xantrix charge controller, which goes up to 40 amps, then I'll put the amp meter with a switch on the negative side to the battery, so that and then I can see, And then what I need to do is I need to have another bus plate, maybe for the meters and the chargers, and have a bus plate for the AC charger, a bus plate, and then the voltmeter, and then any other things that I need, I'll have that bus plate. Well, so this has really been a challenge for me. Just starting with a small system and then trying to add other systems to that. No, if you're out there and you got the money, buy a kit that's expandable. Buy from a good reputable dealer, and that would come with all the instructions. It would come with all the wiring. It would come with all the racking and the mounting hardware and you know, and there's kits you can get that are kilowatt or 2 kilowatt, you know, good size kits. So I didn't do that in the beginning, and with me it was just starting out with a small system and then keeping, you know, trying to add on to it. You know, the battery's the same thing. I need to add that other bar on there, and then use these existing I can get, and use terminals that would normally go on car batteries, and put those terminals on the ends of the rods, and those would be the contacts for both the charge controller and the pure sine inverter. Which people are saying, you know, use stranded wire. Why are you using the bars? Why are you using the bars? It's a stupid idea to use a bus bar on a battery because, you know, the power flows along the outside surface of the copper. And I've looked into that, and I've, you know, asked some of my friends at work, they're engineers, and they say it doesn't really matter. What matters is the connection. It's the contact. It's actually how much is touching on the surface area where the connector makes contact with the bus bar. So if you have a tiny amount of surface area that's making contact, you're going to get a lot of resistance. Whereas if you have a big surface area and a good connection, then that doesn't then the flow of electrons are not impeded through the material. It's like people think that the electrons are bumping from the on the outside surface only, where the electrons actually are bumping on the inside of the material, and that's how the charge, the current, is carried. You know, it's similar to a water pipe, you know, a big pipe of water. It's analogous to that. And another thing I have, here's some of my goals, you know. Solar rearrangement goals. Combine wiring. Integrate onto bus plates. Mount all the electrical boxes, preferably on like pegboard. Gauges, switches. Add switches. Add terminal ends to wires. You can see what I did before. I'm trying to add terminal ends. Route wires through conduit. So all those wires, instead of just bundling them together and putting a zip tie on them, I could run them through a pipe, through like a PVC pipe. Finish the bus bars on battery bank. That would be the rod, and add the lugs on the ends for battery posts, you know, on the ends of the rods. Get a decent voltmeter. I don't even have a voltmeter. I'm using that little Radio Shack voltmeter. I don't have a digital voltmeter. Add switches on-off to the amp meter. Add an on-off switch to the AC battery charger. Get possible lengths of wires as short as possible, like I mentioned earlier, because of resistance. The longer the wire, the more resistance. Consider buying a good combiner box. Okay, I looked into that, and I'm trying to maybe look at an RV supply for like you know, an RV DC existing combiner box, something like that. Used, maybe cheapest I can get it. And then I'm going to use a power cord for the for those 3 80-watt panels, the 2 Series and the Sharp. I was thinking of using a power cord and cutting it in half, and then using the male-female end just for disconnect, so I can move it when I want to move that ladder off the roof. Anyhow, this is some of the problems you have when you start off with a small system and you keep adding on to it. You know, you have to consider where it is and wiring, and then you have the problem of cosmetics, and then you worry about, well, is somebody going to steal it while I'm gone, you know, because you got, like, these things are like, I mean, I've been getting them on online auctions for, you know, a decent price, but still they're pretty expensive. It's like having, you know, $100 bill on your roof, you know. So anyhow, feel free to leave a comment. Maybe you got some suggestions. Maybe you're more expertise at this, better at it than I am, I'm sure. And feel free to leave a comment. Thanks for watching.